morning. Well, at least it's a good morning for myself. I'm over here in Alaska, so it's a little earlier than I'm used to hosting our webinars. But welcome everyone. Hopefully everybody's starting to join in the webinar here. All right, if you want to click through a couple slides, I'll start chatting. So we're continuing our series on networking. Again, I'm Fritz Wichern, in case you don't know who I am. We've got Dave Bohlmann along with us, and then we've got special guest Joel Riley that's going to be contributing any of his random thoughts of wisdom as we go through some Wireshark captures today. Sorry, I haven't had enough coffee yet. As always, most of you who join probably hoping just to catch that KMC hat or Yeti or whatever it may be. So make sure and watch your emails at the end. And as always as well, let us know if you have any thoughts or ideas on stuck on a bucket topics. Send me a note. If you didn't see the email that came out before, Sky put it in the chat for us. We've got a zip file with some captures you can download and follow along on your own computers to make this a little bit more interactive. So if you look in the chat there's a little link to Wireshark captures. If you didn't have a chance to download it yet, you can do it now. And I think that's about it for the intro. Anything I missed, guys?
Nope.
All right.
All right. All right. Well, thank you, Fritz and Sky.
Yep.
And Joe. Good to have you too. So this is the third in the series. The first two, that's also the links in there in the email. We kind of talked about what you do with Wireshark, then last time a little bit about how to use it and some of the filtering and that. So here we thought, since we had quite a bit of good feedback, why don't we actually try to use it here and see what kind of trouble we can cause and get into in that. So that's why we made in that zip file, there are 11 actual Wireshark captures. There might even be some from some of Joe's sites from long ago, although I try to anonymize everything. But so I wanted to go through, it's kind of like from our end, what'll happen is we get a system integrator, one of you all will have a problem, and then we'll try to do a Wireshark and then use that to analyze what's going on in that. So what we'll do when we get into it here, I'll have one slide that kind of describes the symptom. That's what we normally hear. Most of the time it's the device is not talking or whatever. And then we'll pause a little bit and give you all a chance to open up the Wireshark capture. Those are called PCAP files. And then you can look through that, and then we'll talk our way through actually analyzing and that. Before, I guess I wanted to ask too, though, if you want to go along, if everybody that does want to kind of follow along in Wireshark yourself, have you already installed it or not? And do we have anybody that wants to kind of follow along or with their own Wireshark as I'm going through this or not? I'm just curious how much to kind of pause. Maybe not. Nope. Okay. I got it. I'm fighting the cold today, so I apologize ahead of time. Hopefully my meds won't make me fall asleep between now and then. Okay. So, and then Adam, did you already install Wireshark on your PC? So Adam said he'd like to follow along there. No? Okay. All right. So you can start doing that, but that was the link. If you just go to wireshark.org, and then you can download it there. The link, I think, to the first video showed some of the questions it's going to ask you. Normally, you just go ahead and just say okay or yes just with the defaults. So, and then you can bring it up. All right, so first thing is, I think last time we talked about what I call the R's, which is these are the things that the kind of typical symptoms that devices will do or networks will do, and that's what you're looking at in a way. And then the dirty dozen list I mentioned last time, it's really what got configured wrong or what's wrong with the devices and all that. So those are things to kind of check once you find what's going on and that. So so the replaces rabble rousers, the R's. I put in here, this is a repeat from last time, but I highlighted some of the ones that are more prevalent that you'll see. And a lot of times you'll see there's too many whoises, which is devices are going out there trying to discover other devices. A lot of times you'll see the either you get an error for a response or you time out on responses. And a lot of devices do not answer requests from your operating system, from your head end. If it's asking for more than 1 point at a time, we call that read property or write property multiples. And so they'll say, no, I can't do that. I don't support that. And then segmentation too. Segmentation comes in if the message, the response is too large for the what we call the MTU path or the APDU size, and so it'll segment out. A lot of devices do not support that, and so that'll slow down things too. And then finally, just things are devices are just outright missing in the discovery or just not there, and even though you think they're connected. So Wireshark's a good way of verifying if they really are or not. So that's kind of general for the MSTP side. A lot of things we'll see, especially is unreliable token passing. Now you can see that in our BACnet router, the 5051 diagnostic page as well, but you can also see that here in Wireshark. And a lot of times there's so many messages flying back and forth, and we'll see an example or two of that here. And a lot of times that's caused by, if you're using our controllers, that's caused by not having a wait or an interval statement, which means as soon as they get the token in MSTP, they'll send out a request, and that's just all over the place. And so that slows down the what we call the token cycle time, because on MSTP, a device cannot send a message like a request unless it has a token first. And a lot of times the root cause of this is there's just either bad wiring or, again, you're forgetting your wait statements or too many devices on the network, and we'll see a couple of examples of that here too. So that's on MSTP. And then for BACnet over IP or Ethernet, and that includes the routers, a lot of times your problem is your network configurations are not quite right. Or on the IP side of things, the IT guys or somebody set up the subnets wrong or their subnet mask, or even the firewalls and the policies are blocking their traffic. Once in a while, it's actually the switch port, especially if you're, again, dealing with IT, they might forget to turn it on. And once in a great while, it's actually your Ethernet cable. So one of the guys some years back gave me a box of cigars because he was chewing me out for our products, and then I demonstrated it actually your Ethernet cable is bad. It was totally felt so bad. So now, anytime you want, you can always, you get TLC from us. It helps if you send cigars. It might help with my cold today. I don't know. We'll see. Anyway, okay. So, and then last time we talked a little bit about the filtering. So in Wireshark, you'll see all sorts of messages, and that. But the first thing before we do a Wireshark, you want to do your basic troubleshooting. Are your BACnet router configurations right? Did IT make any changes? A lot of times IT won't tell you, but you can kind of surmise that are your cables good, routers good, etc. And you can kind of figure out what's the extent of the problem. It might be that only one area is having a problem, so you can, oh, maybe there's a router there that's offline or whatever. And also it's good to see, what has changed. We usually ask that question, and a lot of times the answer is, well, we don't know of anything that's changed from when it worked, but then you find out there was. And the one thing that's helpful with Wireshark is, can you cause the issue to happen? So a lot of times if you're doing a discovery, well, the discovery kind of causes it. So the idea is you can do a Wireshark capture, and right after you start it, then you want to try to cause the problem. And if the problem is related to discovery, then so you start your Wireshark and then you try to do your discovery and then see what happens. So, and then once we're in Wireshark, what I normally do, you just want to filter with BACnet. A lot of times I'll do just a 3-minute capture. It's about all you need to see what's going on. We talked a little bit last time too about where to do the capture. If you have total control or commander, our pilots, you can do a capture there. If you have connect, you can do your capture on the connect machine. Every once in a while, if you pay the IT guys enough, they might be able to do a capture from the router, from their router. That usually does not happen. And you can also do a capture, an MSTP capture using our BACnet router. Or if you have the old-fashioned hub, Ethernet hub, not a switch, but a hub, or if you have a smart switch that has a mirror port, then you can also capture as well. So once we do the capture, just filter with BACnet, and then I normally just kind of get a lay of the land. Like I said, you can click on the info column and then see, what's going on here. Do I have a lot of errors? Do I have a lot of who is this? And we can then start filtering if we need to try to take it apart and see who's really causing the problem here. So here's just some examples of some of the filters you can put in there. And again, we mentioned this last time. And as we'll use some of these in the presentation here today. See, MSTP frames. If you have an MSTP capture, most of the messages will be just passing the token back and forth. And so what I tend to do is I want to get rid of those so I can see the other messages. It makes it easier to find. So I'll use some of these filters. And again, we'll do that here today. And then sometimes you can look for certain kinds of messages like who is and I ams. I use them a lot of times when you just when you just sort with the info frame, you just kind of scroll up and down, and you can see the messages that might be interesting. Sometimes there's too many of them or whatever, and that's where maybe the filter will come in to help isolate some more messages. And you can actually in Wireshark tell it I want to look for, let's say, any request or response with AV11. And so you can actually you can use a filter like this to see all the messages relating to AV11 or whatever you want there too. So, but like I said, we covered that last time somewhat. That was a review. Any questions so far? So if you have Wireshark, and again, want to follow along, now's the time to open it up. It should open up too whenever you, if you have unzipped those PCAP files, as soon as you double click on one, then it should open up as well. And they're numbered 1 through 11. And I guess there's a cigar. Without further ado, let's go through the first one. So, the first capture, I call it ZB1. So the complaint is some devices are not showing up. when you're discovering connect or commander and device communication seems to be slow. And so this is a PCAP capture, a Wireshark capture, taken 6 minutes using, or it's a 6-minute length using commander. And it's doing that while they're trying to discover with connect. So this is Ethernet Wireshark capture. So first thing we do is just type in backnet to filter out backnet. And then so this is the only backnet messages. And I think last time too, I mentioned if you're using a port other than UDP 47808, which is the standard backnet, you can find that you have to tell Wireshark that you're doing that, and that's in the video. You would just simply add, this one does not have an example of that, I don't think, but instead of backnet, you would just simply say UDP and then hit enter, and then it'll show you the UDP messages. And then you can look in those messages and see if it's using some port other than 47808, and then you can decode that way. Like, so that's in, I think, the previous session we had. So then, I'm sorry, I got to keep moving the camera so I can see. All right, so then I just kind of getting a lay of the land, so I just clicked on the info, and it sorts things out. And when I look in here, it's like, well, you know, this complex ACK, this is a message coming back from a device, from a request. The confirmed REQ, that's a request coming from somebody. And so we've got some acknowledgements coming back, but you can see we've got more requests going out than the acknowledgements coming back. And the other thing I look for is, so that's interesting. The other thing I look for is, are there a lot of who is, and here's, it's not a lot, but this one keeps asking for the same device, and then this one as well. So one question would be, all right, who's asking for the who is, and they keep repeating, so that implies that they're not getting a response back. So one thing that we do, a lot of times people are not sure which device is commander and which device is connect, or which device is the other devices and that. So when you select one of your frames, you can come down here to the Ethernet, or to the frame details here. And here at the Ethernet 2 level, it says the source is KMC controls underscores blah, blah, blah. So that means that this message from 10.254.1.19, this message is coming from some sort of KMC device. It could be a router, a lot of times it's a router, or it could be a backnet IP device of KMC, and it's sending out a broadcast. If it was connect, instead of saying KMC controls, it will show you the Ethernet MAC address of your PC that's there. Or if it's commander, it'll say either a Dell or Advantech here. So we know this is some device. And if you click down here, virtual link, I'm sorry, it says this is an original broadcast. So the implication is this is the actual device sending the who is. It's not being forwarded by a router. And then here, the MPDU just says that it's destined for the broadcast, so everybody should respond. And then the down here, the APDU just says what's repeated up here. This is it's looking for device 311. Now, one thing though is we do not see any IAMs coming back, and that is where you have to be careful where you're doing your Wireshark, because devices, when they send their IAM response back to the who is, they could do it one of two ways. They could either send it back as a broadcast, or they can send it back directly to that device. So since we are capturing on some other device other than Connect, we might not see the IAM actually come back. So simply because you do not see the IAM does not mean it did not occur. but it might not have. And the fact here that Connect is asking every minute, basically, well, that implies it's not getting a response back, and I am. So we're missing 311 and we're missing 3659 400. So it's not too bad. So that's a hint that there's those two devices are not talking. And the complaint again was some of the devices are not showing up. And so we can see from here, well, there's probably 311 and 96,590, 400 is probably not connected or online, or they're off or something. And then the other complaint was the responses are a little too slow. So the other thing I checked for Commander, this is not appropriate with Connect, is you see all these ones here in square brackets. So the way Wireshark shows this, or shows the message, in square brackets, it'll put what's called the invoke ID number. And that number is just like a message identifier to help whoever is sending out messages to identify, which responses belong to which request. A lot of devices can send more than one request. I should say a lot of software front ends and that can send more than one. So normally you would see this invoke ID number increase from 1 to 255. Commander does not yet do that, and so there's a configuration you set in Commander to tell it to use a maximum invoke ID. So the fact that this is set to all of these messages are 1, that means somebody has not configured Commander to send out more than one message at a time. So that's part of the reason why it's low, is that Commander sends out one request and it has to sit there and wait for a response before it sends out the next request. Whereas if the max invoke ID was set to something different, like a 10 or a 20, it could send out more requests, and that typically will make things run faster. Let's see here. Now the part of the question is too then here, why are we, we've sent out all these requests. Let's pick this first one here. So again, this was from after I just simply clicked on the info frame. I can now highlight one of those and click on the number column, I should say. And then these are the messages in order. So here is, again, this device, 146, which is, this is Commander. So here's you can see this, it says Dell down here. This is Commander asking for a point, asking actually for a read property. So that means there's a lot of points it's asking for. And I can go down here and it'll tell me which ones, AI1, MSV1, AV3, and so forth. But it gets no response. And it's sending it to 254.1.10. Now, that might be a router, or it might be a BACnet IP device. And so if you click on, again, highlighting that frame there, we can expand the MPDU. And here it says that the destination is network address 101, and the network address is 101, and the destination is 23. So when you see a destination that is just 1 byte, or something less than 127, that's actually an MSTP device. And so that means this message from Commander at 1.146 is actually going to a router at 1.10, and it's telling the router, pass this message on to this device, 23. That's on the MSTP trunk. So now we do not see any acknowledgements coming back. So that device, whatever that is not responding. And we know it's MAC address 23. So if you have your list of which the MSTP device has MAC of 23, then you can see which one's not responding here. After a while, Commander will try to just send one message at a time or one property at a time, still no responses. And it's not until down here where we see a response, which is odd because it's sending that request to the same device. Well, this one's 20, I should say. Let's back up here. This one's going to 23. That one goes 23. Oh, so they're all 23s. And here's a 20. Here's a 20. And then all of a sudden, we start getting messages coming back from address 20, MAC address 20. And what happened then is, here's an IM router, the network message. What happened is during the middle of the capture, somebody restarted the router. And all of a sudden, we're starting to get some responses back. So in the end, one of the reasons why it's slow is the max invoke ID is only a 1 rather than 10 or 20. And then also what used to not work up here until this time, where'd it go here? Right here, until this time, somebody just went and restarted the router, and then some of the messages started to flow, but these two devices are still offline. So that's the way to figure out is, why are they offline? Since they're probably MSTP devices, you have to look at your MSTP or do a MSTP capture in that. And so here's what we've discovered. We could figure out which one was connect, which one was commander, looking at the Ethernet MAC addresses. Were there a lot of who is this? No, but there were some missing IAMs. There weren't any IAMs. And that again is partly because of, it's the IAMs came back as a unicast message. And then see, commander's max invoke ID is only 1. And then we saw the frame here that where the router got disconnected or rebooted in that. So, and I think I'm using, let me close this. I think I'm using my, not quite there we go. Using the wrong version, sorry. Okay. So those of you kind of following along, any questions or on that first one here? Were you able, or did I go too fast, or should I just go and kind of keep going through this and then?
I don't see any questions, but
okay, all right.
We can keep moving on.
Okay, all right. So don't read this over here because that's the answers. All right, so this one, scenario 2, some devices are not showing up when discovering. Again, the communications is slow. And then, but this is another capture of the same network. So what happened was they went back and tried to fix some things and did another capture. And that's this one. So again, we go back, type in VACnet. And this looks ugly. You can see right away. It's like, what in the world is all these errors and so forth. So again, click on info frame. And here we see, again, commander sending out a bunch of requests. Now, since I selected info frame, it's sorted by that. So you'll see the requests kind of grouped together. And then later on, you'll see the acknowledgements, or actually acknowledgements usually come earlier. So here, commander again is sending out messages, but we're not getting any kind of responses back from the devices. So the question is why, and the hint is here. Commander is sending out a message like this. Let's not sort. Let's just go back here to the number column, see it in order. So here, commander. Again, we know this is commander because it says Dell down here, or Advantech. It's sending a message to the router, telling the router, please pass this on. And then that address, 254.1.10, comes back and says unreachable port. Now, you look down here, And for that second message there, it says it's coming from a KMC controls device. So that either means that either that port, and this port number you can look at over here, it says 47808, that's the port it's trying to use. And this device is saying, well, I'm not listening on that port. But our devices normally don't send this kind of message. It's actually the IP router that'll send that. So the IP router is kind of figuring things out. That's what switches do, I should say, and that. And so chances are, and it's kind of mimicking the Ethernet address for us, pretending to be it, but it's telling us that that port's not available. So that means, and we did not see that in the previous capture. So that means somebody went through there and they probably got a hold of IT, and IT made a change, and then all of a sudden our backnet messages are no longer going through. And that means either the IT guys changed the subnet altogether, and so IP addresses are not available, or maybe they restarted the switch and it was not configured all the way. But these kind of messages here, these are called ICMP messages. Those are normally coming from Ethernet switches and routers. And when you see all those errors, well, then you call up your IT guy and say, why am I, I'm trying to send messages to port 47808 and they're not going through. And so that usually means they set up a firewall to stop you from doing that. So, okay. Makes sense here. Let's see here. Not a lot of who is not a lot of IAMs, lots of errors. Again, ICMP port denial, and that likely is an IP address was changed. I wonder if I could do, there we go. How about that?
There we go.
There we go. That's better. Okay. Scenario 3. This is on a different site. The complaint is there are slow responses from the MSTP devices. And so they took a 3-minute Wireshark capture on our backnet router. So this is MSTP. So we'll go to number 3 here. And so MSTP looks a lot different. You do not have to filter backnet because it's the only messages you're going to see are backnet. And like I said, a lot of the messages here are token passing. We don't typically care about that right off the bat. So we can put in a filter and say MSTP dot, and that, as you use Wireshark, it will remember your filters. And so it will, sometimes you can just find the filter you might already have. If you say MSTP dot frame type == 0, that's MSTP token passing messages. If you say == 1, well, that's pull for master. And I don't want either one of those. I'm going to say greater than 1, because that'll give me everything else, any other kind of messages. So these are all the actual messages that are kind of interest, and there's not hardly any there. In fact, there's no, they always see it's a who is. And you could tell from here, this one says APDU, or let's go MPDU. It's coming from some broadcast address. We don't know where exactly. So we don't know really where it's coming from here. So now, so we don't know yet that much about what's going on. So now let's go back and check our token passing. Since there's not that many messages here, there's a hint that something pretty big is wrong. So anytime you change your filter, just make sure you hit enter for it to take effect. So now let's focus on the MSTP token passing, and let's see how long it's taking for the token to work. So I'm going to say MSTP.FrameType = 0, that's a token pass, and MSTP.Source = 0, because that's normally what the router is. So I want to, basically I'm trying to see how often does the router send the token to the next device. I then enter, and that's nothing. So then I ask the technician, what is the MAC address of the router? And, you know, if they say 0, well, then I say, well, for whatever reason, the router is not in the token pass. So that implies maybe some bad wiring, maybe the router is off. Because even if it was not connected on Ethernet, the router would still, the backnet router would still pass the token. So now I can go in, if I reduce that, get rid of that. What is the smallest source address? And so I can click on source to sort. The smallest the smallest MSTP MAC address is 2. So now I can go back, do that filter again, MSTP frame type 00, and then MSTP.Source = 2. Well, now I see here's all the times where MAC address 2 is sending the token to MAC address 3. And you can look at the time in here. This is about 100 milliseconds. That's probably not so bad, but you wonder, you know, it's still kind of slow. Don't know how many devices are on here. And then finally, let's look at the poll for master. That is MSTP type or frame type of 1. And here we see a whole bunch of poll for masters. I mean, they are just gobs and gobs. And you notice, so what is happening here, 3 looks for device 4, and then looks for device 5, and then looks for 4 and 5 and so forth. Let's go back here. I can sort on number here. So we have a lot of different sources doing poll for masters. So that that means that there's a lot of gaps in the MAC address scheme, and that's really going to slow down things. Now, the gaps could be caused by either you or somebody configuring the MAC addresses to have gaps, between one address and another. Normally you want to do sequential numbers, or it could mean that there's enough noise on the MSTP line that devices are coming in and out of the token passing. But since there's a lot of them, then you go back and see, all right, what MAC addresses do I expect? If I already have gaps in there, well, you want to go in there and fix the gap. If you do not have gaps in the MSTP MAC address scheme, then that implies that you have a lot of errors or noise or something. So you got to go back and check your wiring for that. Okay. Number 4. We have missing devices, slow responses, normal. That's normally what we hear.
It's a common complaint.
Yeah, common complaint. If I had a penny for every time I heard that. So we click on put backnet on here. And then sort with the info frames. I'm sorry, sort with the info column header here. So we do have some, got a lot of responses coming back. That's the complex ACK. We have a lot of requests going out. And you can see the token, or I'm sorry, the invoke ID is increasing, it's changing. So that's a good thing. And we still have, so we don't really, actually in this one, we do not have any whois's or I ams. And this was 10 minutes, I think, so that's interesting. But then here, again, this is, we have a few whois's and they keep getting repeated. These are coming from tritium device. So tritium Jace is acting like a backnet router, and that was, let's see, the tritium is, oh, there's two of them here. So here, this is 100.187, that's tritium. This is a backnet router repeating that. So that's interesting. It should not repeat it because it's on the same subnet. So you have to be careful when you have a tritium Jace on the same network as like one of our routers. Tritium routing is interesting. It's about the best way I can explain it. Even if you turn off backnet routing on a tritium Jace, it doesn't always turn off completely. But still, we do not see any responses coming back. And the fact that they keep asking for these same devices probably means that at least these two devices are not responding. But then also, we don't know for sure what these other devices are. And let's check to see if they're, oh, that's respecting a reply, virtual link. And so this up here, this is Commander going directly to that device and it's not responding. Now this could be a, since there's no source down here, I'm sorry, destination down here in the MPDU, then that means it's Commander is trying to talk to a backnet IP device at this address, 100.52. And for some reason it's offline. It's either offline or again, IT put in a firewall and you don't see any responses back or anything. So if there are a lot of offline devices, then that really slows down the communication. And obviously because Commander will, it keeps trying to communicate with those offline devices. So you have to again figure out why is 10.111 offline? Why is 10.114 offline? Do they match this IP address? They probably do, because it looks like Commander only asks for 2 different IP addresses. So the question is, why are they not responding? And Wireshark's not going to tell you that. It's just going to show you that they're not responding. So
gives you a good place to know where to go start looking.
Yeah, right. Yeah, that happens quite a bit where the complaint is the connect or Commander or total control is not seeing a device. Well, you can go back in Wireshark like we did here, and you'll know right away whether or not the request going out of Commander is going to the right place, and then whether or not there's a message coming back. And a lot of times when the complaint is they're not responding or it's not finding them, it's because, well, they're, according to the Wireshark, they're actually offline for some reason. So, okay, let's see here. I usually ask my students at night about this point, are we having fun? Okay.
It's all crickets from the crowd.
Okay. All right. Number 5. And I'm sorry, there's quite a bit in here. I wanted to show some different examples of real world things that you'll see. So number 5, what was it here? Missing devices, and it's 5 minutes of a capture from Commander. So number 5 here. So again, just type in backnet and sort by the info. So again here, here's the ACT. So that means there are some devices responding at least. We look at the requests. Yeah, they're about the same here. And there's not a whole bunch of who is. Who has, that's an interesting thing. We at KMC Controls do not use that message. So this is some other front end with Inventus sending that out. We don't really care. It's not causing any trouble that we can see. But here we have a who is here, and it's coming from a commander here. And then we have some IM messages coming back. And we can sort by the number here. So these devices here are the only devices that are coming back with an IM. So then the question is, are these the only ones that you expect out there? Are there others? And the answer probably is there are others. And so we can tell from here, well, if they're out there, they're not responding at all. Because this message here, who is from 0 to 4 million, etc., that says everybody. And you can go back on the list here. VPLC says that's the original broadcast, so it's a broadcast from Commander. And the destination is network address 65535. That's broadcast. So it's going out to everybody, and these are the only ones that we're getting an IM back from. So if there are other devices, again, they're not talking. It could be they're offline, or again, maybe some Ethernet switch port was set up wrong or whatever. But the other thing in this capture is you can see again that the invoke ID is 1. So that will slow the traffic down as well. You can see what happens. Commander sends out a message, waits until it gets a response before it sends out another one. So if you're a radio guy, we call that a half duplex, meaning you send out one message and you wait for the response before you send out the next one. And that's what Commander is doing, only because the max invoke ID in its configuration is set to 1 rather than 10 or 20. If that was higher, then we would get the responses back faster, but it would not do anything for devices that might be offline. Okay. And we don't know if Commander is pulling all the devices, simply because if it does not get an IM back, it does not know what address to use to send it. So that's another thing to look for. Okay, number 6. Oh, that was number 6. I'm sorry. No, I'm sorry. Did we just do numbers?
Yeah, you were on 5.
Yeah, okay. All right. Number 6, I'm sorry. So this one, I don't have to do the backnet filter because someone already did it and then saved only the backnet frames. So we go in here, do our sort by our info frames, and we see a lot of acts coming back. So there is a lot of communication. The invoke ID is going up, so that's good. There's a lot of requests here. And here's some more requests. So the fact that it does read property multiple and then comes back and starts doing, I shouldn't say then, but then does one property at a time, that will mean that usually that means that the device does not accept read property multiple messages, and that forces Commander to send one request at a time for one point at a time. And we come down here, that's what's going on there. All right, so here we have a bunch of errors. Why are we getting errors? And these errors are coming back. Let's just pick on the first one, hit number here. So this is 44.171. We go down here, we see that NVIDIA that says Dell, so that means that's the Commander. It's going to 44.176. We can open here the MPDU message. Oh, so MPDU, there's really nothing there. So that means that 44.176 is a backnet IP device, and it responds directly back, and it says error. So we tried to do a read property multiple, And if we expand this here, so Commander is asking for AI 65, 66, 67, and BV 13 all in the same message. And this error comes back, says unknown object. So now the Commander knows that at least one of those 4 objects, the device is saying, I don't know what you're talking about. That object is not here. So then Commander goes back, sends out those same requests, but one at a time. Here's AI 65, 66, 67, BB 13, and they're all coming back as unknown object. So that means, and this is from a JACE, what that means is Commander's trying to talk to the JACE to get these points coming back, and the JACE is apparently not configured to export these points as BACnet points.
Objects.
So someone's got to go back into the JACE and configure that, so that way you export these points as BACnet, which is kind of odd because at some point in the discovery, when Commander was first set up, they had to have been exported as BACnet on the JACE, but then because or else Commander would not know what points to read. So then that means sometime later someone changed it and probably turned off the BACnet export, or maybe they changed the BACnet IDs for the points. You don't know. But here the fact that we are getting a message back from the JACE, and the JACE is telling us error, we know it's not the Commander that's causing the issue. There's something on the JACE. Okay. Yep. Okay, number 7. We cannot write to a point that's on the JACE. And so again, this is a Commander or total, it might be total control, I don't remember, or connect. So we go and filter BACnet. And we can sort by our info frames. So there's a bunch of, here's a bunch of readings. So the reading is working because we get responses back. Here's the request for those reads. Read. Here's a write. And it looks like there's only one write in here. Okay, and then here's some IM messages. So we are getting IMs back to Commander, that's fine. So since the complaint was Commander is not able to write, we can see here, since this is kind of, there's not that many messages, we can just sort and find the write. Here it is. And now we can sort by the number. So here is Commander sending out the write command. And let's see, where is it going? It's going to an MSTP device. Because at the MPDU layer, we see its address 1011, and the destination address is an 8, so that's a single byte. So we know that this 44.173 is a BACnet router, and Commander's trying to write to that point. But that actual device, 1011 address 8, it says the source, that actual device is sending Commander back an error, and it says invalid data type. So I know this is it's actually something on a JACE, but it's still MSTP. So the question is, what kind of MSTP device it is. It's able to read the point, and since it's a AV11, let's see here. AV11, usually in here, it will tell it, what primitive type it is. It should be a real value. But for some reason, the device is coming back saying it's an invalid data type. So there's something wrong with the configuration on that device. But again, we know that it's not that Commander is ignoring anything. Commander is actually getting an error back from the device. And so now you need to go back to that device and see, well, why is AV11 giving an error when this happens? So, okay.
Makes sense. I was going to jump in and say, do we want to, because we're getting close to an hour here.
Yep.
Wanted to see if anybody on the call has any questions, or Joe, if you have any thoughts, and maybe we could always continue on. I think we got 3 or 4 more examples, but as far as this month, we want to keep it to an hour. But does anyone have any questions out there? Or I don't think I've seen anything coming in the chat.
Okay, and we can, if we want to, we can stop here. What I tried to do again with all the scenarios here, so we do have 4 more to go, but we can stop and you can take this as homework. And then if you have, and then have questions, you can email me. But you kind of get the flow here. You just filter BACnet, click on info frames, and see what kind of messages that you see a bunch of. Now, you want to see a lot of requests and acknowledgements coming back. But sometimes, like on MSTP, there might be too many, and that's one of the scenarios coming up here later. But you can see that. Sometimes if you do an MSTP capture, it's too long. And so this shows you how to go into Wireshark and change your buffer size to that way you can sort that way, and then move on. And that's about it. So what you want to do that? You want to just stop here and?
Yeah, we can probably wrap it up. And,
okay. All right.
And then Travis, yep, I think we could make the slides available, and what we can do is we'll send an email out following up with a link to the slide deck in a PDF format. It'd probably be the easiest version. That way folks can see them and are readable that way.
Yeah, and the end here, I just put down the same thing, the same slides from the previous session. These are the different causes. If you have somebody sending out a who is, here's their different causes for that right here. And if you have somebody talking too much, then here's the causes. But again, this was in the what we had discussed last month too. So
I want to say thanks, Fritz, for letting me join. I know I didn't say much, but it's been good the last couple episodes of this, though. Showing everybody how to use Wireshark and getting in there deeper. Like we got a couple guys out in the field that want to go Wireshark everything, but usually it's a wiring problem or some dumb, MAC addresses are not consecutive. Like we'll just go fix that first before you take 4,000 captures and bother you guys with them or whatever. But.
that goes back to the sanity part. You're going to, I usually tell people one of the first things you want to do is take a shark. Just don't guess, because you can figure out a lot of things with a shark. But before you do the shark, you want to do your due diligence. Make sure, like you said, your router's there, it's all configured right, and your devices are there, your MSTP is good, and then you can do a shark. And if you have questions, they have your email, right? Or Sky's, or
they've got mine, and then we can send a follow-up when we'll include both the emails, yours and mine, when we send the PDFs out for everybody.
Yeah, okay. And they can put mine in there too, so whatever you want.
Sky says they have them, so
okay,
I'll trust.
Good. Oh, okay, good.
I'll trust that.
All right. Sorry for going over.
No worries. All righty. Thanks everybody. Right. Thanks, Joe.
Thanks,
Talk
Joe.
to you all later.
Yeah, no problem. See you guys.
Bye.
Bye-bye.